Good morning. My name is Carl Luckwitty. I'm the product manager for Steriflow Valve, a division of Jordan Valve. This morning I'm excited to be here to talk to you about a relatively new product for Steriflow, the patent pending Sanitary Subcooled Condenser. What is this device? Well, it's a clean condensate chamber and steam trap assembly that was designed to be used as a validated clean steam assembly to be installed downstream of a validated temperature sensor. First, let's take a look at the device itself. You can see that the condensate chamber here is the inlet, or here is the inlet. This is the validated temperature sensor T. And then below it, at the outlet side of this condensate chamber, we have a steam trap, a standard, in our case, a standard Mark 93 with a horizontal inlet. That's what it is. Take a look at what this was designed to replace. The SSC was created to minimize or eliminate the normal large space requirement for clean steam trap validated assemblies for SIP. Usually, specifications for these things will call out 12 to 18 inches of tubing between the inlet of the steam trap and the validated temperature assembly right here. And that's a lot of space. That space is there for a reason. Steam traps work, thermostatic steam traps work by subcooling condensate. The trap won't open until the condensate is X degrees below saturation temperature. In order to cool the condensate, I need a drip leg here to hold that condensate to make sure that it doesn't wet or back up and wet the validation temperature sensor. That's why the 12 to 18 inches is there, to make sure, to lessen the probability that that happens. The SSC doesn't require that distance there. It does it in less than 2.5 inches between the validated temperature sensor, there's my temperature T, and the steam trap. 2.5 inches. That's about 5 times less space to accomplish the same task. Take a look at how it works. The SSC works in two ways. One, it's a condensate chamber. We saw that on the cutaway view. So that condensate chamber holds condensate. In fact, the capacity of that condensate chamber is equivalent to about 5 foot of tubing. This double assembly here that you see, that holds the same amount of liquid as does 5 foot of 3/4 inch tubing. So it's equivalent to a 5 foot downcomer. You're never going to back up to fill that. The half version that I've got here, you can order this way as well. This capacity inside here is equivalent to 2.5 foot of 3/4 inch sanitary tubing. Again, in most cases, will handle your needs perfectly. So that's what it is. How does it work? It holds condensate, as we said, but secondly, it dissipates heat. The surface area of the SSC is many times greater than the surface area, the outer surface area of a standard downcomer drip leg. So increased surface area means I'm going to lose heat a lot faster. So I'm going to subcool the condensate faster than I am on a standard drip leg, many times faster. The surface area also was configured differently. We've got, you can see the fins on the SSC. Those fins are there for a purpose. Increases the surface area, also causes convective currents to heat the air, pull it up between, and dissipate heat that way. You can see that illustrated perfectly here in this photograph. Look at the orange and red here on the outside of the chamber. Look at the lack of orange and red here on this downcomer. Very effective at removing heat, which means this trap is going to open sooner, and it's going to open wider and release condensate faster, not clean steam. What does this translate in terms of benefits. How does this help you? Well, let's look at that. The SSC can reduce project capital expense, can greatly reduce project capital expense. How can it do that? Well, take a look at this assembly. This is how you would purchase this, the SSC. It comes with a temperature validation sensor of your choice, or we have many models to choose from, and it comes with a sanitary steam trap, pre-assembled, ready to go. You can also assemble and order from us your own temperature sensor, RTD thermocouple, and if you'd like, we would also purchase for you and install temperature transmitter or a connection head on the temperature sensor. This would be bagged, tagged, and sent to the job site. Capital reduction, you bet there's capital reduction. This would be taken out of a bag and installed. Compare that with taking tubing, cutting it, bending it to shape, welding it, polishing it before you're finished. Major capital reductions in that. Secondly, the space reduction saves OEMs a lot of dollars because of overall space reduction in process skid construction. The same can be true on site at pharmaceutical companies, on job sites, on retrofit jobs in particular, where space is at a premium. You don't have it. You could use the SSC, or you couldn't use a 12 to 18 inch down cone for a AAA. That's all I've got to talk about regarding this morning. If you have any questions or need further information on this, please call your Steriflow representative or go on the web to steriflowvalve.com. Thanks.